What do you mean sig figs? I got my sig
Okay.
figs.
That's
in my
4.
answer.
You're only given
So
3.
let's
That's
talk
4.
about
What do you
inclined
mean
planes,
that's 4 sig figs?
which is
That's
the
four
force,
sig
which
figs.
is the
That's
focus
2
of
sig
lab that
figs.
you're going to do today.
1, 2.
If
1,
my
2,
pen
3,
would
4.
work.
No, you count.
These, yes, you do.
You don't count the numbers in front of the decimal.
You don't. What is the question?
He's
For
like,
sig figs.
he's like, you have 4 sig figs.
Yeah, you do there.
Yeah, that's 4 sig figs.
There's 4 significant figures.
Okay.
13.12.
There's 4
When
numbers
you have
there.
an inclined plane problem,
Okay, that
there's
doesn't mean it's
3
wrong,
forces that are always
though.
present.
What am I supposed to do? Put 13?
No, put 13.1.
Now, here's the story. These are the 3 that are always there. Gravity, parallel, force normal. But you have to remember your equation to calculate force parallel is not on your equation sheet. Okay? The way to calculate force normal, not on your equation sheet. So you got to realize that, oh, and drawing it this way is more technically correct because it shows how the forces are actually acting. Problem is, it doesn't do you much good in terms of trying to figure out the trig functions. So that's why a lot of times you'll see it drawn like this, where there's your force normal, there's your force parallel. That makes that a right angle. Now it makes the trig easy to see, where you can go, oh, force parallel is the side opposite, so that's going to be FG sine theta, and force normal is going to be FG cosine theta. Okay? So that's the pure way to do it. That's the trig way to do it. I don't care, pick one. Okay? But on those diagrams that you all have to draw, personally, I prefer that you draw them like this in terms of here, because it makes it easier to see, because if you draw them in here, it gets all jumbled. If you drew them that way, don't worry about it, don't erase it, just for future reference. Okay. The wild card on this one is going to be friction, because friction doesn't always act up the inclined plane or down the inclined plane. Friction just acts in the opposite direction of motion. So if you look at what's happening like on number 5, you're finding that force parallel. So your answer number 5 should be a really, well, pretty good GPA. Okay?
Weighted or unweighted?
Well, it's got to be a weighted GPA.
Yeah.
Okay?
Sure.
So
No.
here's the story. So if you look at what's happening on number 7, I'm going to say, hey, in reality, there's friction. So if you look at the Winter Olympics, a lot of the Winter Olympic Games are just, from a physics perspective, the force parallel games. You've got downhill skiing, you've got bobsled, you've got luge, you've got all of these things that are happening down an inclined plane. So if you want to win the race, you're not going to alter your force parallel. What you can do is minimize the opposing force of friction. Okay? So literally, what you want to do if you're going to win in the Olympics, and especially if you're any kind of downhill sport, the force parallel is going to be a fixed value based upon your mass. Your only option is reduce the opposing force of friction. So that's why they're like in the tuck position. That's why they wear aerodynamic helmets. And that's why they wear the suits that they do, to minimize that drag. So, here's the story. When you look at friction, like for example on number 7, this thing is trying to slide down, so your friction is going to act up, okay? Because it's trying to slide down, friction's going to act up. However, when you get to one like number 10, how much force must be applied to pull the box up at a constant velocity? So on number 10, here's your box. You're pulling it this way. So if you pull it that way, your force friction is going to act in the opposite direction. So that's why I said you have to be very careful about how you're defining the motion and then what sign that frictional force is going to have. So here's the story. Your answer to number 9 should be around 5. Okay, that's not a bad gap, Sean. Okay. Your answer to number 10, and that's a pretty big gap, should be around 10. That's a big gap. Okay, that's a big gap. And your answer to number 11 should be around the square root of 49.
Okay.
Okay.
Make sure on your diagrams
Okay.
that when you draw that normal force, do not draw the normal force pointing straight up. The normal force does not point straight up. The normal force is at a right angle to the inclined plane. Okay? So it's like this. So as that inclined plane changes, your force normal is always going like that. All right. Any questions?
So like, on number 1, is it okay if you have gravity as negative and like and force normal as positive? Is that
All I'm asking you, don't even worry about negative signs on that. All I'm asking you to do is just find the numeric values.
Okay.
Alright.
Let me just.
Literally, it's just find the numbers. Can you do the calculations? That's it, and then make a comparison. Danny,
Would the signs for 10 and 11 be opposite to each other?
but they're separate
Are they?
well,
Oh, I'm dumb.
so I don't care how you define your system.
Okay.
There isn't a right or wrong.
Yeah.
Okay? Because you might define down as being negative, Gap Sean might define down as being a positive value.
Okay.
So I'm more worried about the numeric values than I am the sign.
Okay.
If theoretically I was looking at the nice convenient spots that you labeled, you know, FN and FP, and I saw that FN and thought in my brain, my small shriveled pea brain, that it looked like the 2 lines were parallel, and I switched around my normal and parallel because I'm dumb,
just erase
and
it
then put
write-
arrows.
Just it takes more.
Yeah, you're
effort
right.
to
You're
just
right. You're right.
to
One sec.
write
Give me one
arrows.
sec.
I hate arrows with passion. So let's go with no.
One sec.
Arrows for these freshmen.
Because the first thing I would do when I went to grade that is go into a fit of probably somewhat mitigated rage. Somewhat.
Oh, when you go to look at my graphs, just know that I was on a bus ride when I was drawing them.
Okay.
They might be a little bit illegible.
Again, you're not on a bus now.
Just 5 graphs.
That's
a
just
lot of
it.
graphs.
It's just 5
That's
graphs.
so many.
Okay. Anything else? All right, Cohen, stop the under camera.